Alrighty, my friends. 1.4 notes. We only have a couple new vocab words today, and then we'll do a little activity over these vocab words. And I have a 6-minute video for you to watch today, so that'll be fun. So it's like a little break. Okay, so I feel like there's just some there's a lot of good visuals from videos that are hard to verbally explain, so I like to throw them in there. Our focus today is randomization. We've been talking about this a little bit when we are conducting experiments, and we want to randomly assign our groups instead of creating bias if we're grouping the people ourselves. So randomization is just a process of randomly assigning our subjects or our people to different treatment groups. And we can do this with a random number generator or other options, I guess, but yes.
What do they do if they don't do 2 problems?
Give them a 4 out of 5. Yeah, take a point off. So we have a different, couple different kinds of randomized experiment designs, but a completely randomized design is when subjects are assigned to different treatment groups through random selection. Okay. So we're gonna focus on today 3 different experiment designs. And then, like I said, we'll do an activity that kind of lays these out and gives you an application of it. First one is called a block design. So basically what you do if you're doing a block experiment design is you kind of group the population or whatever, group the people, units, whatever you're studying. You group them first, and then you kind of do your experiments from each group. So you want to kind of group them the common one would be males and females, and we want to test this on males versus on females. So you kind of decide how you want to group them before randomly assigning or randomly figuring out your actual treatment group or control group. So grouping of the experimental units. We'll say that are similar. And usually these blocks are chosen based on what we're testing. If we think these groups are associated with what we're testing, such as gender. Do we think females react differently than males to whatever we're testing? So we might block off males versus females and then assign our groups from there. So pick your blocks. Based on what is most strongly associated with what you're testing. Okay, so that's one type of experiment design, something called a block. Randomized block design. This one, you separate your subjects into blocks. And then randomly assign treatments. within each block. Okay. So that's a type of a block design. Obviously, you have the word randomized in there. We just talked about what that means. And lastly, we have this one called matched pairs design. So this one's a little bit different. Subjects are paired. And usually it's blocks of size 2. We'll do an example too so you can see this. And then randomly assigned to a treatment. Oh yeah, I kind of remember the difference with this one. So this one, each subject receives 2 treatments. Okay. And I think in this video, like the example they give you is one about like driving a car. Or maybe I read that somewhere else. Like if you wanted to test 2 different like types of gasoline, you might use the same car to go travel on one full tank of gasoline, experiment with that, and then use the same car for the second type of gasoline and compare that, and apply like 2 different types of treatments to the same car. That'd be like a matched pair design. Two treatments, order is randomized. Okay. There's our new definitions for today. That's all we're going to do for definitions. And like I said, I think this video is about like 6 minutes. So we'll kind of watch this and then we'll try our activity. Okay. Probably going to open up on my other computer. Here's a relaxing part for you.
You will remember forever. Grandpa probably had a retirement to give a few less.
In this video, we will be looking at experimental designs. The types of experimental designs include the completely randomized design, the randomized block design, and the matched pairs design. In a completely randomized design, each experimental unit is randomly assigned to a random group to receive a different treatment. Each unit in the same group will receive the same treatment, and at the end of the experiment, you will compare the results from each treatment. Show how a completely randomized design would be used in the following example. A researcher wants to conduct an experiment to determine which environment is best suited for studying, a library, in one's own room, or outside. A total of 30 university students volunteered to participate in the experiment. So we have 3 treatments, the library, in one's own room, and outside. Since we have 3 treatments, we will have 3 groups receiving the treatments. Since there are 30 university students, these 30 subjects will be randomly assigned into 3 groups to receive the treatments. Since there are 30 people, each group will have 10 people, and at the end of the experiment, we would compare the results from each treatment. Let's say that the researcher believes that gender has an effect on the results. In a case like this, we would use a randomized block design. A randomized block design doesn't immediately randomly assign experimental units to receive treatments. We first assign people into a block based on a characteristic that is expected to influence the response to the treatments. In this example, gender would be the blocking variable. So first, we separate our experimental units based on gender. One block will be for females and one block will be for males. There are 18 females and 12 males. Then, the experimental units in each block will be randomly assigned to 3 different groups to receive a treatment. So let's make a diagram out of this. We are looking at a randomized block design, and gender was the blocking variable. We started off with 30 university students, and we separated these students into 2 blocks. One was for males and one was for females. We determined that there were 18 females and 12 males. We will have the females be randomly assigned to 3 different groups. and each group will have 6 females, and each group will receive different treatments. For the males, we are doing the same thing, except we have 12 males, so we will randomly assign 4 males into each group. And at the end of the experiment, we will compare the results within each block. The last type of experiment we'll talk about is the matched pairs design. In a matched pairs design, we are only comparing 2 treatments by using the same or similar experimental units. If we are using the same experimental units, we could have an example like this. What type of gasoline is more efficient? Type A gasoline or type B gasoline? 3 cars will be used in this experiment. Describe how a matched pairs design would be used. If we are using the same experimental units, then each experimental unit will receive both treatments. So we have 3 cars, and each car will receive the 2 treatments, one with type A gasoline and one with type B gasoline. We would use the same car for each treatment, and which treatment goes first will be random. So for example, we could drive with type B gasoline first, then once all the gasoline is finished, we would fill up the car with type A gasoline using the same quantity. And at the end of the experiment, we would compare the efficiency of the gasoline. There are cases when we can't use the same experimental units for a matched pairs design, and we would have to use similar experimental units. For example, a researcher is trying to determine whether or not sleep deprivation has an effect on test scores. Describe how a matched pairs design would be used. Well, we could try giving both treatments to the same experimental units, like we did in the other example. In other words, we could have the same person write the test on 2 different days, one being sleep deprived and the other with sufficient sleep. The problem with this is that we can't have the same subject write the same test because they would know what's on the exam when they read it the second time, so that would be kind of unfair. Instead, we could start off by pairing up students with similar GPAs. So for example, the 2 students with the highest GPAs will be matched up together, and the 2 students with the lowest GPAs would be matched up together. Then, each pair will be split up and randomly assigned to one of the 2 treatments. So for a pair, one person will get the sleep-deprived treatment, and the other person will get a normal amount of sleep. Then, we would compare the results for each pair, and we will also compare all of the results. So for example, if we saw that the sleep-deprived people were consistently getting lower test scores than the people who got a regular amount of sleep, then we can say that sleep deprivation was actually the cause for a bad test score. So let's quickly recap. These are the experimental designs we talked about. In a completely randomized design, each experimental unit is randomly assigned to a random group to receive a different treatment. This is what the diagram would look like. Group N, or treatment N, means you can have any number of groups or treatments. A randomized block design first assigns people into a block based on a characteristic that is expected to influence the response of the experimental units to the treatments. Then, a completely randomized design is performed within each block. This is what the diagram would look like. Block N means that you can have any number of blocks that you want. For a matched pairs design, we saw 2 scenarios, one that uses the same experimental units and one that uses similar experimental units. Both of these involve the comparison of only 2 treatments. If you are using the same experimental units, each experimental unit gets both treatments. This is what the simplified diagram would look like. If you are using similar experimental units, we first pair up similar experimental units. Then, each pair is split up and randomly assigned to one of 2 treatments. This is what the simplified diagram would look like.
Okay. I like that visual.
Yeah, it was good.
All right, now we're gonna do an activity.
Yeah,
You still like.
no, she handed it to me. I really wanted her to lift and she you were there.
Can I ask you guys something? Yes, we didn't actually write.
And it was you.
You,
Exactly. So you don't share.
I didn't steal it though. She listened.
but you didn't write it.
Yeah.
I worked my ball.
No, you
I was
didn't.
quarantined actually.
Oh, that's
So you didn't write it.
I was in 4th place.
fine. No, you
So you didn't write it then. Only the voters do.
Oh, I'm sorry.
Okay.
What are you still up
Yeah, I posted this one on Google Classroom this morning. Okay. You guys did you did an SAT one similar to this, but now we're gonna do it a little bit differently.
So she like found X, but she did not like find the English or those two.
That's okay. You can if everything else was good, you can still go for 5. Okay. So remember that high school that was offering the SAT prep class? We were trying to figure out if that really did correlate to like a higher SAT score. So we're back to that situation. Now they're going to do 2 different formats in which they offer this SAT class. They're going to do it online or by a classroom teacher. The counselors want to know which teaching method will yield higher SAT scores, so that they have allowed us to set up an experiment. We have 50 students that we get to experiment with. They've all signed up to take some of the SAT prep class, some form. 20 seniors and 30 juniors. Okay. Outline a completely randomized design to compare the 2 treatments. So completely randomized is when we don't block them off. We just take our whole population of 50 students, and we'll kind of draw the diagrams like they were showing in the video too, and like we've been doing. We're gonna take our whole group of 50 students. And if we want to do a randomized design, we'll randomly assign 2 groups. So we'll do a random assignment. Random number generator you can put if you want. So we have to label all the students numbered 1 through 50. And we're going to assign them into 2 groups. And we want the groups to be pretty equivalent. So group 1, we'll have about 25 students. Group 2, 25 students. Okay, so there's the randomized design of that by just randomly assigning them into 2 groups. And then you apply a treatment to each group. So what's my treatment in this case? What am I trying to test? Explanatory variable. I guess it is.
Online or classroom.
Online or classroom, good. So we'll assign group 1, say they're the online, doesn't matter. We can flip a coin for this. Group 1, heads are going to be online, tails are going to be in person. Online prep course. Teacher. Prep course. So there's my 2 treatments. I'm not going to add those errors, and I don't want to confuse that. And then from there, we can compare. And my predicted variable would be the SAT scores. Okay. So that's the completely randomized design. That was like the first one we talked about. Number 2 says, the counselors at this high school, I always think it's like Elkhorn High School, EKHS reminds me of Elkhorn, but it's obviously 2 words, so East Kinley. What's the one in High School Musical? East High, right? Bobcats. All right, the counselors at this school hypothesized that the online versus classroom results could be greatly affected by the grade level of each student that were put into each treatment group. They know that seniors generally score better on the SAT than the juniors. How can we adjust our experiment to ensure that there is an even split of seniors and juniors in each class? Draw an outline of the experiment with your modifications. All right, so basically here we're going to block them off before we assign the groups. Okay, we hypothesize that there is a difference between the juniors and seniors, so that's how we're going to block them off so that we can compare the results within those groups and all together. So this one right here, we're going to do a block design. Okay, so we'll take our 50 students that we started with. And we're going to lock them off into their grade levels. So let's say we have 20 seniors, right? 20 seniors and 30 juniors. So these are my blocks. All right, so I'm separating them in something I think that's going to affect my results here. And then we're going to take the seniors and juniors and we'll do our random assignment from there to create our groups. So we can number all our seniors 1 through 20, random number generators. We want to make 2 groups. So since there are 20 seniors, our groups are going to be about 10 and 10. I'm going to call this group 1A, 10 seniors. Group 1B, sorry, I'll do 2A, 10 seniors. Again, we want our groups to be roughly like equivalent. And then we'd apply the 2 different treatments to those groups. So we'll stick with the first one gets the online prep. This one gets the teacher prep. Okay, and then we'll do the same for our juniors. Randomly assign 2 groups. So we'll say group 1B. Since I have 30 juniors, there's going to be roughly 15 of them in each group, and that's okay. It's okay that there's a little bit more than the seniors. And the other group with 15 juniors. Okay, so then same thing, randomly assign the treatment. And then we can combine, well, we could compare those scores like within their groups. We could do it a couple ways. We could compare these scores within just the senior class and within just the junior class, compare their SAT scores. And then we could also combine and compare these. Okay. So there's an example of a block design. Oh, great. Next one says, the counselors are not worried that a student's GPA is certainly going to affect their SAT score. Let's just look at the juniors. We want to be sure that different GPAs are being evenly distributed into the 2 treatment groups. How could we be sure the GPAs are evenly distributed? All right, so this is kind of an example of like a matched pair design where we want to take like similar, obviously we can't use the same person, but we can take similar students. So we're first going to have to put them in order of their GPAs. Okay. I don't love mapping these ones out, so I just kind of like listed here. So First, let's put them in order of their GPAs. We'll say from highest to lowest. Okay, so what we're basically gonna do is we're gonna try to find like students with similar GPAs. We're gonna like match them together, and we're gonna say, we'll randomly assign, like flip a coin since there's only 2 of them. Flip a coin. Say you're going to the online prep class, you're going to the teacher, and then take the next 2 highest GPA. So we're trying to basically find like similar experiment units. So I said, take 2 students with highest GPA and pair them. And obviously you could do this down your list of 30, match the 2 with the lowest GPA. Okay, that's that matched pairs design. Randomly assign 1 to online and 1 to the teacher. And then you obviously just repeat this until all 30 juniors are assigned, and you'd have 15 in each group. Okay. So you have like 15 pairs of students. Flip a coin. Don't always put like the higher one in the teacher prep or something like that. Flip a coin or do random number generator with 1 and 2 to randomly assign them to a group. Okay. There's, I think, 3 pretty good examples of those 3 different designs we were talking about, experimental designs. So on the back, just have like another example, and then we'll call it a day. Okay, so our important ideas, again, I'm not going to make you write out the definitions again. You can have them in your notes, and hopefully after that video you kind of got a good visual. Are our 3 experimental designs. Completely randomize. Randomized block design. And matched pairs. Design. Do you guys want to do this like with a partner? Would that be more fun than just me going over it? If you guys are bored. Partners are all together. Anybody have an opinion? We're almost done. We just gotta do 3 problems, and then you guys can have a little nap if you want. You guys need some candy or something? Okay. A political strategist would like to design an experiment to compare the effectiveness of 3 different YouTube advertisements promoting a specific presidential candidate. She will use 300 randomly selected YouTube users for the experiment. Do you guys even watch YouTube anymore? There's good stuff on there. You can find anything on YouTube. Okay. Describe a completely randomized design to compare the effectiveness of the 3 advertisements. All right, so we have 300 people, 300 subjects here. YouTube users. And if I want to do a completely randomized design, I'm going to assign them a number 1 through 300 and random assign them into 3 groups because that's what we're comparing here, 3 different advertisements. So we're going to do a random assignment. Into 3 groups. We'll just call them group 1, group 2, and group 3. Okay, here's some good math for you. How many people are going to be in each group? 100. Okay, there's a completely randomized design. Now we're going to apply a different treatment to each group. So we have 3 different ads. So we'll let group 1 watch ad 1, group 2, ad 2. And again, we could randomly assign these as well if we wanted to. Group 3, ad 3. We can use those results to compare, or we're trying to compare the effectiveness. So my explanatory variable would be the ads. My predictive variable would be the effectiveness. That's what we're trying to measure. We're seeing if the ads can predict the effectiveness of this presidential candidate's ads. Okay. Describe a randomized block design for this experiment. Just by your choice of blocks. Okay. A way that we could block them off. You might be thinking like we could do genders, but we don't know for sure with the 300, like how many males versus how many females we have. What if we randomly selected 250 males and only 50 females? And we kind of want our blocks to be like roughly equivalent. So a way we could block them is by their age. Like we could list them oldest to youngest, and then block off like 150 of the oldest group, 150 of the youngest group, and then assign groups from there. So we still have the 300. How you doing, Bree?
Good. Are the worksheets still out of 5?
Yes. We have the 300 YouTube users. We're going to block them off into an older group. 100. We'll take the 150 oldest. I wonder what group I'd be in. Younger. Hopefully younger. I don't know. 150. So these are my blocks. And then we'll do the random assignment and assign groups within each block. Hey, Kate, how you doing? Did you finish?
I finished. It's in the basket.
Okay, awesome. Okay. So then we'll take our 150 old folks, randomly assign them into 3 groups. How many people are going to be in each of these groups? 50, yep. 1A, 2A, 3A. Same with the young bucks. 1B. 2B. 3B. Okay. 50 in each group, and then we'll assign the treatment, the ads, randomly to each group. Okay, and then we can compare results within each block. and overall. Yellow. And we can combine and compare. Okay, so hopefully that gives you a little bit better understanding of block designs, match pair designs, and the randomized design. All right, we can just talk through number 3. Why might a randomized block design be preferable in this context?
Older people are more knowledgeable on like the presidential.
Yep, for sure. It at least kind of like eliminates some of these like confounding like variables that maybe we'd have. And yes, you're exactly correct. The old people like kind of comparing them with each other would be a more fitting data than with the younger people. There will be lower variability of the results, making it easier to determine which ad is most effective. Okay. Perfect. That's all for today, folks. We just have one thing left to talk about: random assignment versus random sample. We'll do that tomorrow.